Okay, in this video I'm going to be going over Module 15.1, defining and evaluating logarithmic functions. And so the first thing that I want to draw your attention to is understanding that the logarithmic function are inverses of exponential functions. So the inverse of an exponential function is called a logarithmic function. So here we have f of x equals 2 to the power of x, and the inverse is log base 2 of x. And so if we were to draw this, remember when you do your inverses you always switch your x and y's. So instead of this being 3, 8, it would be 8, 3. And instead of this being 2, 4, it would be 4, 2. And 1, 2 would be 2, 1. 0, 1 would be 1, 0. And our inverse function looks something like this. So this is what log base 2 of x would look like. So I'm going to go to explain 1, which is on the next page, page 746. And we're going to go over how to convert between an exponential and a logarithmic function. So here we have an exponential equation. So b to the power of x equals a. So for example, that could be 2 to the power of x equals 4. And then the logarithmic equation is log base b of a equals x. Or if we were using these numbers, it would be log base 2 of 4 equals x. And so the way that we write this back and forth is I take the base and I raise it to this power and it equals this. So that would be b to the power of x equals a. Well, isn't that the exponential form? So if I go to this table here, we are going to go ahead and rewrite it forwards and backwards. So the base of the exponential is the base of the log. So I would have log base 4 of 64 equals 3. And now for this one here, I start with the base, I raise it to this power, so what is that? 5 to the power of negative 2 equals 1 over 25. Okay, let's do the same thing here. Log of the base, so log base 2/3 of q equals p. For this one here, I start with the base, so 1/2 to the power of n equals m. So I'm going to go through parts of this. So think of each equation as involving an exponential function or a logarithmic function. Identify the function's base, input, and output. For the inverse function, use the same base but switch the input and the output. So this was the output and we switched it to the input. This was the input and we switched it to the output. So that's what it's talking about doing here. Right? With inverses, you switch your x and y. So think of the equation as 4 to the power of 3 equals 64 as involving an exponential function with base 4. The input was 3 and the output was 64. So the inverse function for the logarithmic has base 4 still, log base 4, and the input is 64 and its output is 3. So that's what I just explained using this chart here. So let's see, here are the answers to our chart. Let's double check that we did them correct. Good. And now let's see if we can do this chart here. So log base, keep the same base as your exponential equation, 3. And you're going to have 243 equals 5. Now going the other way, we're going to start with log base 4. 4 to the power of negative 3 equals 1 over 64. And with these, you can actually think about it. Does it make sense? Well, with a negative exponent, you'd bring that to the bottom. So 4 to the negative 3 is 1 over 4 cubed. Is 1 over 4 cubed 1 over 64? It is. So you can kind of check your work to see if what you did was correct. So this one, log base 3/4 of s equals r. Here, we have base 1/5 to the power of w equals v. So go ahead and try your turn 8 and see if you can go from exponential form to logarithmic form, or from logarithmic form to exponential form.